Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
This problem is asking us to find the velocity of a bus during its trip based on a position versus time graph. Now, the key thing here is that velocity from a position versus time graph is equal to the slope. Slope of the position versus time graph. So that means for all three sections, A, B, and C, we are just looking at the slope of the line. Now, one thing to note here is that that means right away you can tell if these are going to be positives or negatives, because if the line is going downwards, it's a negative slope, so a negative velocity. If the line is going upwards, it's a positive slope, so a positive velocity. So my final answers for all of these, if we're looking just at the sign, is A will be a negative velocity, but B and C will both be positives. Now, my rise over run for all these, for getting the slopes, just means we need to find a part of the graph where you can easily measure a change in velocity and a change in time. If we look at the first graph, the first 1 second sees a change of velocity of 20 meters. So that one is going to be our rise of negative 20 over our run of 1 second. So we get a velocity of negative 20 meters per second. If we're looking at B, it takes 1 second for it to go from 10 to 20. So it has a positive change of 10 in 1 second. So it's traveling at 10 meters per second. And for part C, we don't have a nice 1 second interval we can look at here. The closest we can get is to half of a second. And in half a second, C actually goes up by 20. So 20 divided by 0.5 gives us a positive 40 meters per second for our velocity.